Hello students, this is the part B of my video for this WAEC 2025 physics practical preparatory. So in my part A video, I made video about mechanism. That's the first question that WAEC will ask you. So after the video, then I promise I'm going to come up with my own personal predicted question. Remember that in the part A video of this WAEC 2025 physics practical prep, I made the video contains 2009 WAEC physics practical. 2009. That is what WAEC might actually ask you for this 2025 physics practical. Yes, they will ask you the one of that 2009. So then I said that in my part B video, I'm going to be making the video of my own personal predicted question for mechanism. That is for question number 1. But I'm so sorry, when I checked that my predicted question again, I can't find the authenticity in that question any longer. That means the question is no longer that authentic like that. That was why I decided not to work on it any longer. So for the optics, that's for the light, I will not be working on that. I will not be working on that. So if you really want to answer the question of that question number 2 for optics or light, it's better for you to go and study 2010. So I'm assuring you 2010 for that optics. So but this one is electricity, and this is question number 3 for electricity. So like I used to say that all these questions that are giving you is just based on our previous experience and the possible things that might actually come out. So we don't know it yet. I'm just giving you an assumption. These are not live questions, no, they are just an assumption or what the idea you should have. So for the WAEC 2025 physics practical preparatory question number 3, that is for electricity. So these are the specimen WAEC instructed schools to get: 1 potentiometer, a rheostat, 2 cells of 1.5 volts each, a voltmeter is 0 to 2 volts, an ammeter, a jockey, a key, 1 standard resistor label of this, and connecting wire. So you'll be provided with all these specimen on that day of the exam for those that want to answer question number 3. Now, and I wrote something here. I wrote a note here. Now look at these notes. So in this note, I wrote it there that as light increases, the voltage also increases while the current decreases. Yes, why did I write this? I wrote this because in physics practical, what they actually used to mark is the trend. They don't used to mark it's not the table that they really mark. What they mark in that table is not the number you are writing, no. It's just that you have to observe the trend of how your table goes. So they believe that once the length increases, then the voltage will also be increased while the current will decrease, so or vice versa. So that's what they mark in physics table. They mark your trend, the way the trend goes. So take note of this particular trend. Okay, so now let me now go to the predicted questions I have for you. For this question number 3. Now look at this question. This is question number 3, which I have for you. So the question says that, as you can read it here, it says that instructions and procedure. So connect the circuit as shown in the diagram. That is your setup. Do you get that? The way the setup will be on your question paper. So close the key and adjust the rheostat to get different readings. Then use the joy key to find balancing length L on the potentiometer wire. Then number 4, for each adjustment, record the current I from the ammeter. 1, record the voltmeter across the resistor Rx using the voltmeter. So record the voltage V. Record the voltage V across resistor Rx using the voltmeter. And the next one is record the balancing length L, that is using as L. So the question under it is now plot a graph of V, that is on the y-axis, against I on the x-axis. Then determine the slope of the graph. And then the C is, what does the slope represent? D is, from your graph, determine the internal resistance of the cell. Then the next question, which question he says that state 2 precaution taken to ensure accurate results. And the F says, why is a potentiometer used instead of a voltmeter? So these are the questions I have for you. Yeah, this is the table I came up with. Though I should have shown you the practical aspects of this work, but me showing practical aspect of this work, it wasn't that feasible for me. So I'm so sorry about that. But look at this trend on this table. So you can notice that this length decreases. As this length decreases, this SME serial number is just a number. So this length decreases. As the length decreases, then what happens to the ammeter? So what happened to the ammeter? So the ammeter, what it increases. What happened to the voltage? So the voltage also what? The voltage also increases. So now look at the trend I wrote here. I wrote it here that as length increases, but although in this case the length decreases, so the voltage also what increases. In this case the voltage also increases while the current decreases. So then, but here now the current what increases. So it just means that everything must not increase. Like all of them must not be increasing. This is the table I derived from the particular question, whereby I'm going to use it to plot the graph. Then we are going to answer the questions under it. So from the graph plotting, you'll be asked to plot a graph of V against I. That is what basically they were asked to plot. So now let's go into the plotting properly. So having this table here like this, then let me plot my graph here. Let me roll my margin. So like I've said earlier, that if you measure this guy like this now, so this is one of this is in centimeter. Yeah, as you can see, centimeter. Let me place it like this, centimeter. So 1 centimeter is representing one box, because this type of graph is tiny, a small box. So there are some graph that you will not see this first tiny, like the kind of box will be kind of bigger than this, the boxes will be kind of bigger than this. So looking at this place like this now, we have 1 centimeter representing one box, 2 centimeter representing two box, 3 centimeter representing three box, 4 centimeter representing four like box. This. So now the back of the graph sheets like this, as you can see it very well here. So now let me just from the question, we are told to plot what against what. We were said plot a graph of V y-axis against I x-axis. So V y-axis, I want to label the graph now, and then I x-axis. So I, that is your ampere, which is your current. Let me just write it here. I. What's the unit? That's what? Ampere. Ampere. So if you like, you can put this arrow here like this and wrote x-axis. So I'm trying to label the graph, and then this place is going to be your what? Your V. Let's see it clearly. V, that's your what? That's your voltage. So V, so voltage. So you can leave it like this now. Okay, so after labeling your graph like this, sometimes I like putting this arrow here. Maybe I'll write it as what? Y-axis. I just like putting it there, y-axis, and here is what? X-axis. X-axis. So I've labeled the graph. Then what do? Then the next thing for me is to write my scale. So I'll write the scale here. Then what's going to be the scale? The x-axis and then the y-axis. So for the x-axis now, it's going to be for the x-axis now. That's going to be let's check the table. So this is the x-axis, and the x-axis is what? The current. The current in ampere. So we have 0.3, 4, 5, 6, 7. And remember that I said in my first video that your graph must cover 3/4 of this graph sheet. So and here we have 0.3, 0.4, 0.5, 0.6, 0.7. So the best thing to do here is that if I should take here from 0.3, 0.4, 0.5, 0.6, 0.7, so that will be the best. Yeah. So that will now be like from here, from this particular here. And this, remember that this place is 2 centimeter. If you should measure it with ruler, yeah, that's 2 centimeter like that. This place. is 2 centimeter, as I can see it here. So that's 2 centimeter. So for my x-axis, that will be 2 centimeter, representing how many units? So that will be 0.1 units, 0.10 units, 0.10 units. So you don't need to start your graph from, 0 0. It does not necessary. So you just have to start from here by saying 0 point. What do you have here for your current? You have your 0.3. So it's 0.30. Then here is 0.40. Here is 0.50. What about here? Here is 0.60. 0.70. You can stop here, but you can proceed if you wish. 0.80 and then 0.90. Okay, so now looking at the V, that's for the y-axis now. So that's the voltage. So the voltage also have the same reading together with the ammeter. Mind you, this reading is just my own personal reading. So your reading the exam will be different, totally different from this. Please, this is just like a guideline. Anything we did, just like a guideline. Your readings is going to be very different. So do your setup very well. If you are not getting your setup, call your teacher to assist you in it. And basically, most students, let's be realistic, most students they they really depend on their teachers to assist them in their readings. So what they are going to tackle on the day of the exam is just the graph, to be realistic. So that's how I'm emphasizing my time on the graph more. Now for the y-axis, the y-axis is not going to be, so the y-axis is not going to be, let's see, I should put my 0.3 here, 0.3 here, then 0.4, 0.5, 0.6, 0.7, or let me say, because of this y-axis is kind of more longer, so let me start from 0 here, 0 from here. So this 0, let me take it 0.1, 0 point, let me say 0.1. So I'll be making my y-axis as also 2 centimeter, representing 0.10 unit. So for my y-axis will be 2 centimeter, representing 0.1 unit. But let me write my 0.1 like this. Let me start from 0 and not like this. So it's 0.1, here will be 0.2, here will be 0.3, here will be 0.4, 0.5, 0.6, and then here will be 0.7, then here will be 0.8. You can proceed by saying 0.9. Yeah, at this top edge here, 0.9. So and like that and like that. Now this is my scale. The graph is ready. Now it remains the plotting. So for the plotting now, from here now, I can actually say that I was asked to plot 0.3 against 0.3. So 0.3 here against 0.3, that will be sorted here, as you have seen. 0.4 against 0.4 will also be here as well. 0. What is the next? 0.5 against 0.5. 0.5 against 0.5, it will be here. So 0. What? 6 against 0.6. 0.6 against 0.6 to be here. Then 0.7 against 0.7. 0.7 against 0.7. So that will be here. So this is the graph. So let me take my line of best fit. This is giving me a straight line graph, a very perfect straight line graph. So let me take my straight line graph here. Now, the next question you're going to have here is that, now let's look at this. They said plot a graph of V, y-axis against I, x-axis. So we have done that, and this is the graph. It's this permanent, the perfect straight line graph. So the next question here is now to determine the slope of the graph. So let me take my slope from here. Let me just take my slope from here. from here to this place, from here to here as my slope. So this place is going to be my, normally it's supposed to be my x2 y2, but you don't call it x2 y2, you just have to call it what, your i2 v2. Whereby this one is going to be your x1 y1, so it's going to be your i1 v1. And then your slope which is supposed to be y2 minus y1 all over x2 minus x1. The same thing as your y is your what, v. I'll be changing v against changing what, I. So changing v against changing y will still be the same thing as your v2 against v1 over I2 against v2 minus v1 over I2 minus I1. So your v2 is going to be what? If you trace it here, that will be 0.7 for your v2. So 0.7, and then for your v1, if you trace it here, that will be 0.5 minus 0.5 all over your I2. Your I2 from here now, your I2 is what? 0.7 minus your I1 from here is what? 0.5. So is 0.5. By the time you look for your slope is going to be, this is 0.2 all over 0.2. That is what? 1. So your slope is going to be 1. And if your slope is 1, then what does that interpret? It interprets that V over I equals to your resistance. So that's going to be, your resistance is 1 ohms. So that means your slope is 1 ohms. 1 ohm. Because the ohms comes from V over A. That means volts over ampere. Volts over ampere. And volt over ampere is what? Resistance. And that is what? 1 ohms. So just 1 ohm. Remember this formula, V equals to IR. Whereby R equals to V over I. Your V is your voltage, your I is your current, that's in ampere, while R is resistance. So by the time you do the slope in form of this pattern, which is what, R equals to V over I, and any answer you get, you can actually write the unit as voltage per ampere. But the best thing to write is just to write ohms. So your slope is 1 ohms. So that was what the slope interprets. Now is a, so you can just say the slope represents the resistance Rx. No, resistance is Rx of the standard resistor. Whereby since V equals to IR, so the slope of V against I gives R. That's resistance. So V over R gives what? And V over I gives what? R. So that's that about that. But you can also explain it based on what I've shown you on the graph sheet. So, or probably you write it like this, or you explain based on what I show you on the graph sheet. So answering the next question, which is question number, which is D. This says that from your graph, remember that we have answered A, we have plotted this against this, we have determined the slope, then we have interpret what the slope represents. So from your graph, determine the internal resistance of the cell, that's small letter R. E equals to V plus IR. Each dry cell has an EMF of 1.5 volts. So, and if you connect it in series, the total EMF volt is going to be what? 2, because we are asked to, because we were given 2 from the specimen. So that's going to be 1.5 volts plus 1.5 volts. So the EMF, so the E is going to be what? 1.5 volts plus 1.5 volts, because we are given, that will be 3 volts, because we are given 2 from here. We are given 2 cells, that's 1.5 volts each. So that's how we're going to get our E, that's the electromotive force. So after getting our E from the formula, then next is to get our what? Our V. So from the graph, from your graph, you can pick any readings from your graph to represent your V and your I. Let me open the graph again. You can pick anything from your graph. So let me say, if I should pick my readings, if my V is what is 0.7, then my I is going to be, it's also going to be 0.7. So you can pick your readings, your V from here from the graph, and the same thing will go with your I. The same thing as well. That's 0.7 and 0.7 together. Because from here it says that from your graph determine the internal resistance of the cell. So we have gotten the E, that's the electromotive force as 3 volts. Then our V is going to be 0.7 volts. That's the voltage. 0.7 volts. And then our I, that's the current, is also going to be 0.7 ampere. 0.7 ampere. So from this now, we can now calculate the internal resistance. The internal resistance is going to be what? It's going to be, let me collect my light down. That will be E minus V over I is equals to R. So from here, if you substitute the value there, that equals to 3 minus 0.7 all over 0.7 equals to what? R. And finally, R is going to be 3.29 ohms. So that is for the internal resistance. Although I only show you this work should in case if they ask you, do you get? Should in case if they ask you that you should calculate, you should find from your graph, you should determine the internal resistance of the cell. So this is just the basic things for you to calculate. Your E is your 3.0 volts from the question. That's the electromotive force. Your V is from your graph, I is from your graph. Then this is the formula. Then you get your R. And the next question here says that you should state 2 precautions taken to ensure accurate results. So that's for the E, question number E. So for the question number E, the 2 precautions to say is that number 1, you avoid parallax error when reading meters. So I avoid parallax error when reading meters. So that can be your first one. Or you can also say that okay, you use the key only when taking readings to prevent battery drain. Use the key only when taking readings to prevent battery drain. When taking readings to prevent battery drain. You understand that? So let me add more for you. But mostly they used to ask for 2. So another one they can still ask you. Another one you can include there is that you ensure the jockey touches the potentiometer wire gently and briefly. So you ensure the jockey touches the potentiometer. The potentiometer wire gently. Potentiometer wire gently and briefly. Okay, let me add one more again to make it 4 so that I can pick 2. So another one I still want to add for you is that clean all connections to reduce contact resistance. Yeah, that's also another one for you to add. Another precaution you need to take note. You have to clean all connections to reduce contact resistance. So then that was what clean all connections to reduce contact resistance. Clean all connections to reduce contact resistance. resistance. So that's that about the question E. Now for the F says that why is a potentiometer used instead of voltmeter? Yeah, so that's the last question I have for you. If you asked that question, let me write it here. F. So if you ask that particular question, what reason will you give? You're going to say a potentiometer measures potential difference without drawing current. Yes, which make it more accurate than voltmeter. So that's a good reason for you to give. Let me come again. Said a potentiometer measures potential difference without drawing current. Hence, it is more accurate than a what? Than a voltmeter, which may affect the what? The circuit. So that's a good reason for you to give. If they ask you why is potentiometer used instead of a what? A voltmeter. So a potentiometer measures potential difference. Measures difference without drawing current. Without drawing current. Without drawing current. Hence, it is more accurate. Yes, it is more accurate than a voltmeter. It is what? It is more accurate than a voltmeter. So it is more accurate than a voltmeter, which may affect the what? The circuit. So it is more accurate than a voltmeter, which may affect the what? The current. The circuit rather. So which may affect the circuit. So those are the possible questions I have for you under the question number 3. If you have any question you have for me, or if you're not getting anything right from the video, please just comment under the comment section by asking your question, and I'll reply to all questions very well. This is just a guideline of what you should do on the day of exam for WAEC 2025 physics practical. This is Matt Kim. Please kindly share this video to your friends, classmates, and everybody. Give us a like thumb, give us a nice comment, and I wish you best of luck in your exam. Bye.